Welcome everyone. Today we are diving into the fascinating world of generative media. We will explore what generative models are, the different types, popular tools, and their ethical implications. So let's get started. So first of all, what are generative models? So generative models have become widely popular in the recent years, but at its core these models are about teaching a machine learning to generate new data that resembles its training data. There can be multiple examples. For example, if we train a model on images of cat, it can generate new realistic images of cats. This technology powers applications like ChatGPT for text generation, style transfer in apps, and even deepfake videos. So it can have multiple applications like image or video creation, text generation, audio synthesis, and we will briefly see a demo of all of these three use cases. Now, what are the types of generative models? There are many types, but there are the main two types that we will focus on. And these two types, which have revolutionized the field in the recent years, are transformers and diffusion models. Transformers are great for tasks like text generation, while diffusion models excel at generating high quality images. Both have unique strengths and are used in various applications. Now, one of the most popular platforms for accessing generative models is Hugging Face, which offers over 2 million models for various machine learning tasks at the time of this recording. So, the Diffuser library provides state of the art diffusion models, and the Transformer libraries, and these offer standardized interfaces for tasks like text generation, and these tools make it easy to use powerful models without starting from scratch. Now let's come to the first use case, that is generating images. So using the diffusers library, we can access models like Stable Diffusion 1.5 to 3.5, 3.5 being the latest at the time of this recording. We have also another set of diffusion based models called Flux, and but we will focus our attention on Stable Diffusion 1.5 since we can run these models without any difficulty on the free Google Colab notebooks. But the procedure for calling either Stable Diffusion 3.5 or Flux, these are exactly the same, and you can try all of these. So we can generate an image of a photograph of an astronaut riding a horse with just a few lines of code, and we will see that shortly. And this process involves loading the model, then defining the prompts and generating images, as simple as that. So for this lesson and most of the lessons in this course, we will be using a free Google Colab notebook. So make sure to change the runtime type if it's not already T4. So we will need GPU for this. So you can change it from here, change runtime type. Here it's already T4, so I will just reconnect it. It may take a while. And now we will load our Stable Diffusion model and we will see image generation. So the first time you run it, it will download these models from Hugging Face Hub, and it may take a while because these models are a few GBs in size. So let's run it. But in the subsequent runs, these will be already cached, and it will use the cached model. So it will be much faster. So once you have the pipe set up here, so you just need to call Stable Diffusion pipeline. So pipeline is nothing but just some workflow, and most of the steps that you will need is taken care of by pipelines. So we will look at pipelines in detail in later lessons. So here the purpose is just to give you a feel that how good these generations can be. So you just need to create a pipeline. You set the device to CUDA if you have one, otherwise CPU. And then you just give a prompt in natural language like a photograph of an astronaut riding a horse. And then based on the result, you plot this image. So it's taking a while to download the models, and then once these are downloaded, it's quite fast, the generation process. So let's wait for a few seconds. I think most of the download is completed. Now it's doing the generation process, and this 50 shows 50 iterations, and we have our image ready, and you can see an astronaut riding a horse, and next time you run it, it will give you a new generation. So let's run it again. And if you want to keep the generations consistent, you have to define a seed. So if you fix the seed, you will get the same generation, but if you don't fix it, you will get a new generation each time. So actually a pipeline was already loaded. I could have just written this part. So this time we hope to see a different astronaut riding a different horse. And here we get it. It's different from earlier one. Now let's come to generating text. The Transformers library allows us to use models like GPT-2. And again, GPT-2 is not the state of the art. We have much better models, but for the sake of simplicity and ease of use and using it on Google Colab Notebook, we will focus on GPT-2 for this lesson. And for instance, we can generate texts. We can write a few lines of the text as a story. Let's say we are creating a story and we write first few words or sentences, and then GPT-2 will complete it in its own creative manner. Now let's see an example of text generation using transformers. So the process is very similar. We import pipeline from transformers and we specify the pipeline, that is text generation. It can be classification and many other pipelines. And the model we are using it GPT-2. So here I pass first few words of the story that we want to generate. So I pass like it was a fine sunny morning. So I give some starting context, and we are limiting the length of generation to maximum 50 tokens, and then we are printing the result. So you can increase it and you can get more. So now GPT-2 has completed the text for us. So it says it was a fine sunny morning, which comes from here. So it was a fine sunny morning when it came to the new house. So I set it all on fire. My son and his sister were running away from the house. So I jumped in. One of them broke my leg and fell onto my. So here this 50 tokens is exhausted. So next time you run again, you will see some different version of it. Now let's come to the third use case, which is generating audio. So generative models aren't limited to images and text, and these are I think most popular in images and text, but you can also generate audio. They can generate sound clips. For example, using MusicGen, which is Facebook's model, we can create music based on text description. For example, we can write a soothing melodious flute music, and it will generate a music based on this prompt, and we will see a demo of this. Now let's see a demo of audio generation using MusicGen. Again, the process is very similar. So we are passing text to audio. So the pipeline is text to audio, and we are using the model MusicGen small. And the prompt is soothing melodious flute music. And it will take some time and generate it for us. So first time it will download this MusicGen small model. So from the next subsequent generations, it will be much faster. So the music is generated and it's 29-second duration. So let's play this music. So pretty impressive. So there may be some degradation in, of course, quality of this generation while recording it. So you can play for yourself, and you can try different prompts, and I'm sure you will appreciate how good these generations are. Now let's look at some of the ethical considerations in generative AI. So while generative models offer remarkable capabilities, they also raise important ethical and societal considerations. Privacy and consent are major concerns, especially with realistic image and video generation. Bias and fairness are also critical, as these models can inherit and amplify biases from their training data. For example, you may have some image generation model which are trained on some particular race or some particular region of the world, and these will tend to generate images from those regions or races. So these introduce inherent bias in the models depending on how they were trained. Then regulation and oversight are necessary to ensure responsible use of generative models. So now let's see the history and evolution of generative models. So these models have come a long way from early rule-based systems, to deep learning, and then there have been key advancements including CNNs, RNNs, and GANs. Today, transformer models like GPT have set new standards in NLP and text generation. Similarly, diffusion models in the field of image and video generations. So the future of generative AI is rapidly evolving, and with the new models and applications emerging constantly. Even at the time of this recording, I am sure there may be a few more models being uploaded to Hugging Face Hub. So the future holds exciting possibilities for creating expression, problem solving, and innovation.